Okay, YouTube, this is my third video in my module on reference angles and using them to evaluate trig functions. But in this video, we're going to focus on how to evaluate trig functions for angles that happen to be, say, greater than 360 degrees or maybe less than 0 or less than 360 degrees. But the way this is going to kind of work for us here is to realize, first of all, if we were to go over 360 degrees, we could recall from earlier sections, if you're studying trig, that coterminal angles would just be two angles that end or terminate in the same place, okay? And so anything that's a coterminal angle with another angle is basically they only differ from each other by multiples of like 360. So for example, here I say, negative 45 and 315. I know this is kind of a small sketch here, but if I were to go down 45 degrees from here, we'd say 45 degrees this way would be the same thing as 315 degrees this way. And to get one from the other, we could say, well, negative 45 degrees. If you were to say add 360 degrees to this, just like basically go negative 45 degrees and then just spin around one full time, you'd land back in the same spot. So, I'd get 315, not a shocker. Or, 10 degrees and 370 degrees, this is just kind of common sense here that if we have a 10-degree angle and we have a 370-degree angle, which would be 360 plus another 10, you would have two angles that necessarily they land in the same spot. So we say here's our 370-degree angle. Fact of the matter, though, is this. I mean, if we were to evaluate, say, the sine of 10 degrees and the sine of 370 degrees, you would get the same numbers anyways because it's the same triangle. It's the same triangle. So here's going to be our method. To find values, I write here, of trig functions for angles larger than 360 or, say, smaller than 0, negative angles. Instead, here's what we'll do. We'll just pick an angle between 0 and 360 that happens to land in the same spot anyways, because who wants to deal with an angle bigger than 360? I'd rather deal with something between 0 and 360 and just call it good, because everything else is just extravagance, So it's very important to point one thing out before we kind of dig into this, find the exact value of cosine 495 over here. But it says in this little spot here, the trig functions of coterminal angles must always be equal. Okay, so this kind of makes sense if you think about it. If I have, I'm going to go find the sine of, say, this angle here. Here's my angle. And I go find the sine of that angle plus another 360. And I can make that squiggly a little bit better. That angle plus 360. Or I would go back and do this again. And I say, we'll do the negative angle. They all land here. But the fact of the matter is, look at this, look at this. They make the same triangle regardless. So here's what we say. We say the sine of some theta, right here, sine of theta. It'd have to be the same thing as sine of that original angle plus or minus some 360-degree rotation, because if you're adding on 360 or you're taking 360 off, you're pretty much landing in the same spot. In other words, they are coterminal, okay? So we can write, say, for sine and cosine, we can write it like this. But in general, coterminal angles, they all have the same, say, sine, cosine, tangent. So we might as well pick a convenient coterminal angle. So now let's go ahead and take a look at what I've written up here. Go find the cosine, the exact value of the cosine of 495 degrees. So we're going to start by sketching our angle here. A 495 rotating counterclockwise here would be at least a 360. 360 plus another 90, that would be like what, 450 plus another 45. I suppose we could say it's like it's over here. I mean, if one thinks about it, we say here's where it would stop at least. And it looks like this. We say, okay, 360, 360, 450, 450, 495. Okay. So here's our 495-degree angle. All I would like to do is advocate for doing this. Well, what other angle between 0, okay, so between 0 and 360 degrees would have given us something that stops in the same spot? So one way to find this is just to take our original 495 degrees and say maybe subtract off 360. And so we get 5, 3, 1. I'm thinking here, and I'll switch colors actually. Let's go to a greenish, because that would be really contrasting with what we've got here. 135-degree angle here would have given us the same thing. A 135 would have given us the same thing as this because they are coterminal. So if anybody asks you to find the cosine of 495, you say, nah, I'll just find the cosine of 135 because I happen to know that they're equal based upon what we've written down here on the bottom left. So a cosine of 135, let's use the steps we did in our last video. A 135 has a reference angle. Let's see here, reference angle of 45 degrees. So we will say, okay, well, if theta is 135, then its reference angle, theta party hat, is 45 degrees. Now we'll also do this. We say, well, in terms of the second quadrant, we're finding cosine here, so we have all students Take calculus. Is cosine positive in the second quadrant? We say, well, no, sine is the only thing that's positive in the second quadrant. So we'll write this little note to ourselves. Cosine is negative in the second quadrant. So we have this. We shall rewrite this in terms of its reference angle. So we'd say it'd be the same thing as the cosine of 45, its reference angle, and it would happen to be negative because cosine is negative here. So we say negative cosine 45. And anybody who's studying trig knows that the cosine of 45 should know is radical 2 over 2. So we get the exact value, negative radical 2 over 2. So the moral of the story is this. If you were to go find the cosine of 135 in the first place, you would have gotten negative radical 2 over 2. And that has to be the same thing as the cosine of 495, like we wanted in the first place, cosine of 495, because 495 lands in the same spot 135 does, or terminates, or is coterminal with.